Okay. It also says, this is a little bit different because this is a little different way to think about acidic solutions, a little bit different way to think about acids. But I say here that non-metal oxides. So, when I say non-metal oxides, something hooked on with oxygen, but the other thing with it is not a metal. Sulfur, phosphorus, anything like that. And this has implications industrially, like for acid rain and that kind of thing. I'll explain. But non-metal oxides can react with water to form acids. I'll show you what I mean. Take carbon dioxide. Why is it that, first of all, with global warming, we know that the carbon emissions and all that kind of stuff gets trapped up there, forms a little bit of a blanket, all that kind of stuff. So we've got CO2 with global warming. But what else? In terms of chemistry, not just thermodynamics, but what about acid rain is becoming more and more of a problem. Now, it's not rain that's going to fall from the sky and melt our skin kind of acid, but the pH is slightly changing. The more industrial growth that we get, the more the pH changes in our rain. But realize, too, that that's not just a local phenomenon. When currents pick this stuff up, the acid rain that we produce here in the Midwest and on the East Coast can travel all the way to Europe by the time that these currents are done and all of that. So global change, we've become a world that has become so interlocked in terms of all of our global economy and all that kind of stuff, and our rapid industrialization. This is spread all around the world. So the stuff that people are doing in Europe, whether you think it affects you or not, it does. And the stuff that we're doing affects them. And we need to recognize that very quickly before things get too bad. But anyways, with increased carbon dioxide emissions, one of the things that can happen is the same thing that happens in your pop can. You mix in carbon dioxide and water, guess what forms? Carbonic acid. It's just the reverse of what we just looked at. H2CO3 normally decomposes into water and carbon dioxide, right? But under pressure situations and things like that, you can cause the reverse to happen. You can take carbon dioxide, you can take water, put it together and form carbonic acid. So guess what happens? You burn a lot of fuel. You release a lot of carbon dioxide. Our industrial plants, it would be great if we ever figure out this nuclear energy thing in terms of being able to get rid of all the waste. But we can't yet. We can make nuclear energy, and it's very efficient, and we can make a lot of energy from nuclear energy, these power plants and things like that. But the problem is we have this huge amount of waste that we don't really have a good way to deal with. So it's not a feasible alternative, at least right now, unless a lot more money gets focused on it and away from other places. But we still rely a lot on coal. We still burn a lot of fossil fuels, even in the industrial settings. So we're still cranking out a ton of CO2 into our atmosphere. What's going to happen is that reacts with rainwater. Okay. Now realize that by the fact that we are biological beings and all the other animals that we interact with, we all exhale CO2. So it's going to go up there, and rain will always be slightly acidic. It will never be neutral. And the reason it will always slightly be acidic is because we all breathe out CO2. There's nothing we can do about it. But there's no need to crank out a giant whole big bunch of CO2 just to expedite this and make it even worse. So this is combining, this is forming. The same thing can happen with sulfur dioxides. That's a big one from volcanic eruptions and coal burning. You see commercials now about like cleaner coal. Maybe you've seen some of these commercials. What clean coal is not clean at all, but it's reduced amount of sulfur mostly and other things, but especially sulfur in the coals that they are burning to prevent this from happening. That forms actually sulfur dioxides that are made can actually react with oxygen and water up all in the atmosphere and make sulfuric acid actually in our atmosphere. That will get collected and form an aqueous solution that comes down in the raindrops. Okay? Nitrogen dioxide can do the same thing and form nitric oxide. If you guys ever watch, what one is it? Dante's Peak, where the grandma is up there trying to save the little girl and jumps in the lake on the crater lake thing there on the side of the volcano. It's erupting and just digests her legs and eats her flesh. Well, it's a little hyperbolic. It's a little exaggerated, but the theory is there. If you have a lot of, when you get a lot of this stuff spewing forth from the earth during a volcanic eruption, you get a lot of this up there. You get some heavy acid rain following a volcanic eruption. Technically, it's possible, especially with this and this. Right around that volcano, especially, it'll interact with all the oxygen and the water vapor in the air and create elevated levels of acid rain that would fall down. But in that particular movie, it was a claim that the entire lake just turned to concentrated sulfuric acid. Very unlikely. This is very low concentration. It's enough to affect us biologically, but not nearly enough to stand out in the rain and watch our skin melt. So the idea of taking an entire lake and turning it into the concentrated level of sulfuric acid that could digest human flesh is a bit over and above, but it makes for a good movie. The theory is there, though. You can see where that theory plays out. Okay, now acids will react with most all metals, but not necessarily all of them. Gold, if you trust me, I can take a solution of hydrochloric acid and take your gold, assuming that it's pure gold. If there's any alloys, it might digest part of it. But if you have something that's pure gold, I could drop that into an acid solution. You probably wouldn't see anything. You wouldn't see anything happen. Okay, I pull it out, wash it off, give it back to you. You may not want to trust me with that, but it can happen. Okay. It just depends on the properties of the metal. Most of the time you'll react. Obviously, if you take a piece of zinc or aluminum or magnesium and drop them in there, that's a whole different ballgame. It's going to fizzle and spat like crazy, and it's going to just put that metal into solution very easily. Remember James Bond one of the movies had a little pen that he used to squirt on the iron bars to digest them that he walked out of. First of all, very unrealistic. If you had, this is why I watch. The way I watch movies is a little bit different. But yeah, well, I suppose you could design a container that would house like sulfuric acid without digesting the pen. But the amount of concentrated, because you can only get it so concentrated, the amount of concentrated sulfuric acid that it would take to digest iron bars on a prison is nowhere near the amount you could fit in a tiny little pen. I mean, if he had like a 50-gallon drum of it, and he was sitting there spraying it, maybe he could get a little bit off of there, but not with a little pen. That was a little far-fetched, but it makes for a good TV, I guess. And MacGyver was the greatest, man. Now that show was awesome. Give me a Hershey bar and a paperclip, and I'll blow up a town. Duct tape and bubble gum. There's always a place for gum somewhere. So. All right. So here, if we drop magnesium in hydrochloric acid, did we do this in one of the observations that we did? I don't remember. But I mean, you can see what happens. Everything fizzes like crazy. Now, what's happening here? Why is it fizzing? Why do we get this effervescence? Well, look, hydrochloric acid, solid magnesium. What is happening? Magnesium chloride, right, and hydrogen gas pulls off, and it separates. So that's why all these bubbles are coming up. All right. Whenever acids react with metals, pure metals, okay, not a compound, but like you have here, like a solid, one type of atom metal here, you're going to produce a salt, like in this case magnesium chloride, and hydrogen gas. That's always going to be what's evolved from this particular type of reaction. So if you take aluminum and drop it in sulfuric acid, you're going to get aluminum sulfate, which is an aqueous salt, and you're going to get hydrogen gas as a result. Okay. All right. Now, metal oxides are anything that has like iron oxide or aluminum oxide, any kind of metal bonded with oxygen. Okay. So acids can react with metal oxides. What happens? When acids react with metal oxides, they again produce a salt and water. Let's take a look. Sulfuric acid reacts with aluminum oxide. Okay, remember how we got these numbers. We can reverse this, bring it back up. We get 3 positive, 2 negative. Those are the charges for those particular ions. What happens is they switch. The aluminum takes the place of the hydrogen. You get aluminum sulfate. And what do you get out of that is the oxygen and the hydrogens then come together to form water. Okay, so there's an example of metal oxide reaction. You don't have to memorize these. You should be able to see and look. Just look. When you have these things mixed together, recognize that it's an acid, what's going to happen. This is not a base. Okay? This necessarily, you're not going to classify these things as acids and bases, but these are just different types of reactions that acids can undergo. They can react with stuff. What will happen? What's the neat stuff that happens when you mix acid with things? You can just go back to regular double displacement chemistry here. This guy and this guy are going to switch places. I'm going pretty quickly through this, forming this, because you should already know why this is written the way that it is. If I'm going to take sulfate ions and I'm going to combine them with aluminum ions, you have to, at this point, already know how I'm going to put that together. I'm going to need, I know that aluminum is a 3 positive charge. I know that sulfate is a polyatomic ion that's a 2 negative charge. How many of each am I going to need to put this together? Okay, so you have to figure that out and write it accordingly. I'm not going to go through that explanation again. You'll have to do that yourself.